How's it going, everyone? Evalu Gonzalez here again, and in today's video we're going to now wrap this series of videos. Finally, take a look at now how the async and await actually work behind the scenes, how we're going to build an async and await works using the inner functionality that JavaScript provides to us. And this will be the final video of this entire course from the hard part of JavaScript, the asynchronous nature in JavaScript. So this course is taught by Will Sentence, the CEO of Codesmiths, which Codesmith is this software engineering and machine learning residency headquarters in New York and California, where now the idea here is to, well, in this course, look at how now the asynchronicity works before the EX6 and EX7, and now how each one of those new specifications provide you is features that allow you to work with the asynchronous nature in JavaScript. So not only on the browser, but also for the server. And how by looking is at now this particularly new concepts into the language, like the iterator and generators, which is the first, is a way of how we can access to our data. And then with generator is a way of how can we now control the flow of data. We can now is understand what is the async and await is doing behind the scenes, so we can have better precisions of how to communicate that and understand those concepts. So just a quick recap of the course itself here, so we can then move on to what is relevant for today's video. Is the introduction. Understand is all of these different basic building blocks. So for example, like the threads of execution, the variable environment, whether it's global or per function, which is another feature, function execution context that contains its own thread of execution, as well as their variable environment, the call stack, the closures, and which is a nice little bonus features on JavaScript, and then how now the asynchronicity works in JavaScript as a way to say, all right, so if we want to defer a task that will take some time to complete, we use is this passage function, these callback functions that allow you now is to access to this or to send a function to outside of the JavaScript wall, in this case the browser, okay, and then after that time is over, that function will be added to the something called the callback queue, where now this is when you have is your store or your callback queue, where now the event loop, which is the inner mechanism in JavaScript engine that is responsible to take a look now at if the call stack is empty, meaning I'm actually evaluating something. If it is, let me wait for that until that is done. And then, all right, now if that is empty, it is time for me, the event loop, let that callback pass through the call stack. So now when JavaScript detect that, it say, oh, I have something to run. Good, let me now evaluate this function, this callback function, and then remove that from the call stack, and let the process repeat that again. So this is something interesting because this particular approach is actually one of the asynchronous features that allow us is to run code that will take some time to complete in JavaScript. Okay, hey, I want you to now defer this task sometimes in the future, and while now I'm evaluating other pieces of code. Okay, so the issue with this is because it's not readable, and especially when you're working in Node applications. So what happened is that because you are defining all of these nested operations, and then you end up with the pyramid of doom to say, hey, I need this data after the time is over, and so on and so forth and so on. So the ECMAScript designers say, hey, you know what, it'll be better for us to actually create some way that give us is the code, or give us this asynchronous code in at least in one level. All right, and that's exactly what Promise is doing. It's the ECMAScript designer now specify on the spec, hey, this is the object, the promise that will represent is the eventual completion of this task that will take some long time to complete. Okay, you will have is now the state, which will tell you at which state you are currently at, pending, fulfilled, or rejected. And also you will have is the value property, and now an array of unfulfilled and unrejected, which now this is when you're going to add is those callback functions that when that async operations now is whether it's fulfilled or rejected, this is what you want to do. And the way to know where you're going to store these particular functions, whether it's rejected or not, is on the microtask queue. So the microtask queue now is adding all of these callback functions to be processed, okay? When the value actually update, okay, and trigger is the proper callback, whether if the function is whether if the promise is resolved or rejected. Whoever is doing that mechanism, whoever is saying, hey, this is a rejected or this is a resolved, is something that is outside of our control. Especially if we're using is the fetch or the read file. This async or this API that allows us to, the first, talk to the network, and the other is to talk to our local files and how to read them. So in the case of the fetch, this is what allows us to do, okay? And when that value, when we get that value or not, the value will be updated, and then it's going to decide, okay, now this is the callback that you're going to run under the .then or under the .catch. And that makes exactly a lot of sense, because with that, now we have is the ability to say, all right, let me define this, okay? Yeah, let me define this, and now let the event loop, which will be responsible to say, hey, JavaScript, this is the function that you should execute when you're handling this promise, okay? And it's going to pass that from the microtask queue to the callback queue. So this process is, by design, the event loop will go to continuously evaluating all of this callback in the microtask queue until exhaustion. So that can be quite problematic if you're continuously adding new and new micro tasks, or job as they call that on the spec, the job or the micro task queue, as you continue to add this micro task to the queue. So you will end up having an endless evaluation of that. Again, something to remember and to recap. Okay, so now that we know this particular model of using promise, which is actually now how this allows us the promise, the callbacks, the web APIs, the event loop, as well as the micro task queue, is what allows us to now defer a task to be complete sometimes in the future, okay, and find a way to now defer a task until the job is done, while we are now running is the code without blocking the main thread. That's something interesting, because with that particular mindset, okay, we are now able is to not only run is promise in an async environment, or promise in promise in an async environment, or promise in a, how do you put it? Promise in an async environment. Jesus, not only single promise but also multiple promise. Okay, using the promise that all as a way to say, hey, now I'm getting all of this promise or all of these async operations, okay, in this iterable, something that we're going to talk about, and I want you to now give me the result once you do that. So, because after all, the fetch returns is a promise object fulfilled with the response object. Once it is fulfilled, now we have this ability to actually run code or to run multiple async operations, okay, and know which, or dealing is with parallelism. Okay, as well to say, hey, I want you to now do all of these async operations at once. So using the promise at all and the promise at all settle. The difference between the promise at all and the settle is that the promise at all allow you is to now work with okay. The promise dot all is allow you to now define promise that depend on each other, okay. Where promise dot all settle is for promise that they are they don't depend on each other. They're independent of all of this. But in any case, this is something interesting as a way to look at this async tasks, async operations. And now, before going to the async and await, I'm going to make a quick recap of the iterators and generators. So iterators is just describing a way of how can we access data, which is a task in itself. So instead of being imperative, we are now going to be more declarative. In other words, the only thing that we care, especially when we're working with collections of data or objects, is that is not only how can we access to that, again, which is a task in itself, but what we're going to do with that data, what transformations we're going to apply to this data, okay? And because of that, now iterators provide us is a convenient protocol that say, hey, anytime you want data from this collection, okay, you're gonna get that as flows of data. We also look at how can we build our own iterator using a using is a closure, okay, and how you have to be careful about the programming logic to define that, to manage this inner state. So with iterator, we can now, by following this protocol, the iterable, which describe is the iterative behavior of this function that will be consumed by the for of syntax, for example, or any syntax that can now identify is this iterable batch, okay, under the prototype symbol dot iterator, and then you define is what'll be is the behavior of this algorithm, all right, and the other is that what'll be the output that this iterative protocol needs to produce, okay. as a standard way. This is the iterator protocol. So what here you now is return is the next, okay, as well as throw an error, but this next is required, which is an object that return, which is a function that return an object with the value, and done as a way to indicate, hey, this is done. We actually iterate through all of entire data structure. This particular protocol is what allow us is to know now not only have control over flow of our data chunk by chunk, okay, or a sequence of data, but also to produce that, okay. And with the case of generators, which is a special type of iterators, now generators allow us to have now or to define an iterative algorithm by writing a function whose execution is not continuous. In other words, this particular function or these generators allows us to control the flow of our data that we're going to generate for that. And that's something interesting because, for example, we can is now define is, hey, I want you to now run this function, okay, and when you encounter is the, for example, I want to read this line, I want to read this line of code. So when I'm writing is all of this line of code, okay, I want now to, when you reach to the end of that text, okay, generate that and give me that as a way to consume that. This is one of the great things of this generator as data consumers. In fact, this is an example that now the duality actually mentioned, right? Especially on the generators. Generator in depth. Okay, blocking async functions. What are generators? Way of creating generators. Exactly. And here is when we look at this data generators as generators as iterators. Data production. This is the example that I actually are describing here. Is that, hey, I want you to produce this new, I want you to yield this value. I want you to yield this another value and another as data productions. Okay, ways of iterating over a generator like this and returning from a generator. This is an special type of iterators, not a function. Okay, so when you define your generator and when you run the first time, it creates a generator object for that again is inherited from the iterator approach, which means that this is a type of iterator that now have is the next property that will contain is the value as well as done and some other properties. So why this is important? Okay, especially take a look now at the generators here as it is. As a way to look at now this, right? This is the inner method, which inherits from the iterator, okay? Which now this actually implement is the iterator protocol, which is this is an iterable. Hey, this object is going to represent is the behavior. It's going to represent is the iterative behavior to be consumed for 4 of syntax. That's one. And the other is that the way how now it's going to produce all of this data to be consumed by the 4 syntax is through the iterator protocol. Okay. So this is an object that now produce these standard ways of objects. So that's interesting. That's great, because now that we know how generators actually what generators are and what generators allow us to do. What are the several use cases for that? So generator as iterators, as a way to say data productions, okay, which is the example that we use even with recursion, okay. A generator as observer, now data consumption, okay. So as consumer of data, generator object conform to the second half of the generator interface. So interface observer, which is something that observer no, it's not like that. Well, anyway, as consumer, a data generator object conforms to the second half of this generator interface observer. Okay, as an observer, a generator pauses until it receives inputs. There are three kinds of inputs. Next, send normal input, return, terminate the generator, and throw signals an error. Sending value via an input. Okay, so one of them is the data generator as iterators, and the other is data consumptions, which is something that now the generators are going to receive data. Okay. So hey, this is the data that I want to pass to this generator, whose execution is not continuous for this iterative algorithm. All right. One of them is to yield, the other, which is the produce. This is what I'm going to produce, data production, and the other is data consumption. Okay. Hey, I'm going to pass now to the next function as a data. Okay. Data as an observer. Okay. As a way to play now with this functor or this generator, which this is now the approach that it can take. It can just only produce data, or it can also consume data. All right. Data that you provide to them. Okay. We now call genObject.next, which starts the generator. Execution continues until the first yield, which is where the generator pauses. The result of the next is the value yield in line A. Okay, undefined. Yeah, the result of the next here is the value yield in line A. Exactly. What is the value yield in line A? Nothing. But remember, this function or this generator returned in this format, in this standard, in the iterator protocol. Okay, in the value here as long as it is. Okay. In this section, we are not interested in what next returns. Okay. Undefined because yield doesn't have an operand. Okay. In the next section, in this section, we're not interested in what next return exactly. We don't care about what next return. We actually is now sending data to the generator as an observer or data consumptions. Exactly, return, but because we're not using it to send values. Because we only use it to send values, not retrieve values. Okay, send and retrieve. We call next 2 more times in order to send the value A to the first yield and the value B to the second yield. Exactly. So the first time is actually with undefined, okay, the first evaluation, and then we call next 2 more times in order to send the value A to the first yield, which is this, and the second value B to the second yield, which is this. That's right. So if, in fact, actually, let me put this at practice. Let me put this at practice, and that is function here, data consumer. Okay. And you say, hey, console log here of started. Okay. And when you now do this, console.log with the template string 1.yield that this is a reserved keyword that only exists inside of this. Okay. And then we're gonna repeat this with 2. And finally, we're going to return is that this is done. Result. So when you return result in a generator, you're saying, hey, enough. Stop the execution. We went through all of that. Okay. Okay. All right. Okay, cool. Cool. So here, we define is this. Let gen object here. What we have is a data consumer. We run this as a way to get this generator, where now initially we say gen object 1 dot next, and we want to pass something to that. For example, like string A, right? And now initially it's starting with yielding that, because that's the first things that it's doing, is yield that. So the next time, now yield is the value of A. Interesting. Oh, because okay, let me actually, because after all this is a gen we're passing that, so initially is this. Okay, and now we are sending is the data. Okay, so initially is yielding that. Okay, which is okay, so initially is yielding that. There's nothing there, so then we're now passing data to that. So now the generator is acting as a consumer here, as an observer, as a data consumption. Well, when we pass this, now it's going to replace the value of this, evaluate this expression, and then throw the next one, which is actually is going to return is the A1. And then when we now run the next one, so we say, hey, I'm going to pass you this value, all right? Evaluate that statement, and then return that which is done. Exactly. So this is now the process of how you are now making is this generator as data consumption. Okay. So the first next. When using generator as an observer, it is important to know that the only purpose of the first invocation next is to store the observer. It is only read for input afterward because the first invocation has advanced execution to the first yield. Therefore, you can send input via the first next. Exactly. You can send input via first next because this is actually act as the first invocation. You even get an error if you do. The following utility function fix this issue. The coroutine. To see coroutine works, let's compare the wrap generators with a normal one. So we're here, we say, hey, wrap.next hello. What it contains is the generator functions and call that next. So you are effectively creating it with this coroutine is a closure. The wrap generator is immediately ready for input. For that, the normal generator needs an extra next until it is ready for input. Exactly. Yields bind loosely. Okay. Return and throw and that kind of thing. Preventing termination, throw and single line error, processing asynchronously push data. Processing asynchronously push data. Yield the full story. Example, yield forward next. Okay, generator as coroutine. Cooperative multitasking. This can be quite advanced. Okay, as coroutine. Generator lazy execution. Examples of an example of generators. Implementing iterables via generators, like in our case, something we are now quite familiar to do that, right? Infinite iterables arranged by generator for lazy execution. Lazy pull. The next two examples show how generators can be used to process a stream of character. Extract numbers. Lazy push generators as observables. Generator as observables. Generators as observables. Send ABC. This is an iterable and the receiver. Send ABC and the okay. Send now the collection, the data structure, followed by the behavior, log items. It's interesting. Items of yield, and it's because it transformed this. Because we are sending is that exactly. Because we are sending that iterable and the receiver. Because we're sending is that 1 and 2 and 3 and 4. Step 1, tokenizing. Extract numbers and add numbers. Cooperative multitasking via generator. Pausing long running tasks. Mhm. Lastly, this is a scheduling function that we can use to run count up. Cooperating multitasking with generators and Node.js style callbacks. Read files, process R like this. For let f of the file name, let content yield read file. But again, anyway, communication sequential process and inheritance is where this is actually get all of this. So the whole point of this is to now understand that generator can be used as a as a data consumption by passing its data to that and then do something with that, or by act as generators or by data productions. Hey, is that function that's going to return something that. So with this particular approach, with the observer as well as the which is data consumption and the data production or generate, now it's time to take a look at the async and await.
Wait, can we just appreciate for a second, or appreciate yourselves for a second? You've incorporated into your mental model every hard part of the JavaScript engine here. The entire web browser features part, the microtask queue, the only person who talks about microtask queue really is a guy called Jake Archibald, truly gifted. I highly recommend him. Brilliant British speaker who's a developer evangelist at Google, truly gifted explainer of concepts and sharer of
Drawing a star with dumb matrix. Interesting.
So, Jake.
Hello.
Oh.
Right, let me get comfortable.
Yeah.
Jesus, your last one was an hour long. Let me get comfortable first.
This one's going to be shorter.
Yeah. Don't.
Famous
lost
last
all
words.
trust.
Yeah.
That's interesting. Okay, this is interesting. Very, very, very interesting. It's a way to now look at him. So okay.
Of entertaining, humble anecdotes, as is the wont of my people. And he talks about the microtask queue, the only person who does. That's how advanced this stuff is. And you've combined all that with a feature of JavaScript in ES7 that only just got released. Generated an async await. And you built async await from scratch. This is async await built. If you get a senior dev interview question, which is going to come up more and more, I think, can you build for me async await from scratch? We just did it. We just built async await from scratch.
Just built Redux Saga, basically.
Even better, we just built Redux Saga from scratch. Let's try and inflate our achievements even more. We just built the JavaScript engine from scratch. There we go. I feel particularly proud of all of you.
Let's try. That we write React Saga, man. Because after all, React Saga is what it's doing is behind the scenes that
All right, so we're going to do this though.
using generators for
Final
that
code is going to be
as a way to produce this when you get that.
doing the nicely, prettily wrapped version of this using the async await or the async function declaration style, which is going to just prettify this slightly more for us. All right, for the first time, my beautiful people, for the first time, we are able to return back into a function's execution context after we've left it. We're able to do so using our return next element.next method that guides us back into the create flow execution context. We manually do so using our next method call, which was triggered by the triggering of our do when data received callback that was attached to our future data promise object. But this flow inwards and outwards, and it gets complex. And so JavaScript gives us a async function that's going to automate that process of going back into the create flow function. It's going to say, don't worry, we don't have to trigger going back into it. Instead, we're going to go automatically back into it. We're going to pass the response object value back in as the evaluated result of the yield expression and store that straight in data. It's going to simplify all of this code for us with the help of the new async functions. Async await simplifies all of this and finally cleans up our inversion of control problem of callbacks. We're going to see that now, for the first time, we don't define a task to be done beyond our control much later on. Instead, we're going to go into create flow, set up some work, set up a task that takes a long time. That is our speaking to the web browser that speaks to the internet, gets our tweet, 200 milliseconds brings it back, and then we're going to somehow get back into create flow to continue running our code sequentially. No need for a triggered function on the promise resolution. Instead, we auto-trigger the resumption of the create flow execution.
Exactly. Instead of actually going forward and backward here, which is something exactly what you're doing with function generators, is like by calling is the next, you're going into the execution of that generator function, and then when you find yield, hey, it's now produce or go back to the or go out of this execution context. Okay, you go out from this execution context, and hey, this is what you asked for. This is the data that you were asked for that I produce, that I yield for you.
That functionality is still added to the microtask queue though. All right, so here we go. Lessing, line 1, what are we doing?
We're going to declare an async function called createFlow.
Excellent, createFlow is defined. It is a function. It is a brand new type of function, an asynchronous function.
Okay. Enough.
Line 1, what are we doing? Sean, default Victor.
Value?
Value, which is undefined, we ain't got anything in it yet. That's status, which is pending, you don't have to worry about that.
Okay, as a way to now evaluating is this. As a way to evaluating is this.
But before we get to that, you lock. Return next element, a special object here returns out the value being yielded, pause it, running through a function hitting a yield statement as a backpack of data, we can, with its value being pass back in the value from the returned request, the response object that came back into the promise value. Wow. And that is exactly what we're going to do here. We can use the ability to pause createFlow's running and then restart it only when our data returns. We get to control when we return back to createFlow and continue executing by setting up the trigger to do so, which is the next method, to be run by our function that was triggered by the promise's resolution when the value returned from Twitter. It's a little bit of a sort of loopy back and forwards. It's all going to be automated by async await. We're going to build async await from scratch using this generator function concept. And we're going to sort of tidy it up, wrap it up using async await. We're just going to automate a few of the pieces. This is our final code. These last 2 slides are our final code. Line 1, what are we doing? Sean.
No, okay.
Return next element, contain a call to next. We get done by our function concept. And then we're going to tidy it up, wrap it up using async await. We're just going to automate a few of the pieces. Line 1, what are we doing? Return next element, a special object with a next property on it, a method that when that is called, runs, starts, or continues the calling of create and execute that function, and then continue execute returning to that. Here return that holds on to it. Stream flow return next element. Look how is and those are known as element. One through a function, go back in function now, get to control cell, which is execution context. Condition in which we're now getting to if we could request a promise auto triggered when that promise gets its value with its value here. When we run auto wait from scratch, attaching some functionality to be auto triggered when that promise gets its value back, and what if that triggered functionality inside of it contained a call? call to next that took us back in.
So we can use the ability to pause the create flow running and then restart it in its own like this. So basically is async generators. Okay, because the concept here, because the concept of all of this, of all of these async generators is to now take a look at the ability. Okay. Because now is to actually take a look at this ability. Okay. Because the value proposition of generators, okay, is that the value proposition of generators is that act as a function to consume data. You act as a data consumer. Okay, as a data consumption function, or act as a data production function. You know, we can consume data with the yield keyword. Okay, with yield keyword. Okay, or it can act as a data productions with yield keyword by passing values using the next function, okay, or act as a data production like this, okay, act as a data productions with yield keyword without us passing any argument to the next function. You know, that's, I think, this is the two concept here from this: data consumption and data production. So when you now understand what this generator can allow you to do here, and especially as a way to see how can we actually understand what is doing all of there.
My goodness. And we're going to store that blessing as what, in what constant inside of create flow?
Data.
Continue with synchronous code, and then when that long-term task, really clear with yourself that we do not store in data, just pending, you don't have to worry about. But powerful statement, it's which enters line, it is out. It's going to actually kick us out the evaluated result. What does it do in JavaScript, Ben?
It's kicking
Exactly.
out.
So the fetch
It's kicking
statement
out.
to be the output of return next element dot next, which is stored where, Victor? Future data. Excellent. And this promise object has what properties by default, Victor? Okay. Let's make sure it's clear as a promise. To be thrown out to be the element dot net promise object. To make sure it's clear as a promise. Where, Ben?
Future data.
In future data. So to make sure it's clear as a promise. Not very. And dated, she's back. Be really clear with yourself that we do not store in data this promise. Okay, is updated when fetches background web and on fulfilled. So let's put that over here. There's our output of return next element dot next, which is then stored where, Ben?
Future data.
Mm-hmm. So let's start by evaluating this code here. Okay, and then this let's start by evaluating this code here, and then this yeah, let's start by evaluating this code here, and then this. Okay, yeah, let's start by evaluating this code here, and then evaluate is the future data cons, and then evaluate the future cons future return next element dot next on the diagram. Okay.
In future data. So let's put that over here. There's our promise object. Not very nicely drawn. There's our promise object with value is undefined and on store anything in data because the yield keyword is so strong. Like imagine like it's a return statement. Fetch does a wealth of stuff in our
XML HTTP request.
XML HTTP request, the XHR feature. Look at this, everyone. It's all good. Is it complete?
.value.
Future data dot value. Excellent. Is context. We went inside. We set up data, but we didn't get to even assign anything to it. To the right hand side. So now finish all the fetch work. We've yielded back out, back in the global execution.
Yeah, we're passing in the on fulfillment.
Exactly.
Thing.
Exactly. Can I switch it from on fulfillment to on fulfilled?
Yes.
It's a hidden property. It's on fulfillment.
This function's also called do when data received, not display.
Oh shit, okay. Alright, we're losing it. We're losing it. Okay, good. Thank you, James. And it's on fulfillment is what it says on in the actual spec, if I remember right. I mean, we don't get to see this. We can't even access this property, so I guess it's not the end of the world what it is. We just know it's there. We can't even access. We can't, console log it. To see that we can't even access this property, so I guess it's not the end of the world what it is. We just know it's there. We can't even access. We can't, console log.
Now this, okay. Yeah, that's right. So now this, as it is, so now this is what happened when the fetch function is evaluated, okay, and passes to the future data, exactly, and then passes to the future data as a promise with the response object as value once is fulfilled. right? So that's exactly what we are doing here. And then we can have access, and then we can now do something as a way to trigger is the data. And then, exactly, on the future data dot then, and then on the future data dot then, do when data receive, do when data receive, okay, do when data receive statement. We are now exactly, and then on the future data, then do when data receive statement, we are going now to yield that result, where in this case is console.log that data. Now is when we actually can pass the data to that, which is at the end of the day, this contain is now a promise. Okay, the future data contain is now a promise with an object with the response, where now is in there, where we're going to call is the return next element from that, where we are going to pass the data from the then, but again, exactly, okay. Ooh. So we can console log our data. This back and forward process is what the async and await is saving us. As a way to say, hey, I want you to now run the functions there. I want you to now run the function there.
Yeah, on fulfillment. String hi. And what is that going to update? That is going to update execution context. We manually do so using our next method call, which was triggered by the triggering of our do when data received callback that was attached to our future data promise object. But this flow inwards and outwards, and it gets complex.
So the back and forward process, this
And so to our future data promise object. But this flow inwards and outwards, and it
exactly, this flow of inwards and outwards, not quite sure what is inwards and outwards, by the way, it's because you don't need that, man. It's inward. Oh, really? Enough. Hey, what are you doing? Inward. Okay, inward and outwards. All right, inward and outwards. But this flow of inward and outwards is what the async await is saving us.
gets complex. And so JavaScript gives us a async function that's going to automate that process of going back into the create flow function. It's going to say, don't worry, we don't have to trigger going back into it. Instead, we're going to go automatically back into it. We're going to pass the response object value back in as the evaluated result of the yield expression and store that straight in data. It's going to simplify all of this code for us with the help of the new async functions. Async await simplifies all of this and finally cleans up our inversion of control problem of callbacks. We're going to see that now, for the first time, we don't
inversion of control.
define a task to be done beyond our control much later.
So no need for a trigger function on the promise resolution. Instead, we auto-trigger the resumption of the create flow execution, and this functionality is still added to the microtask queue.
Instead, we're going to go into create flow, set up some work.
Of course, because after all, this is a promise.
Speaking to the web browser that speaks to the internet, gets our tweet, 200 milliseconds brings it back, and then we're going to somehow get back into create flow to continue running our code sequentially. No need for a triggered function on the promise resolution. Instead, we auto-trigger the resumption of the create flow execution. That functionality is still added to the microtask queue, though. All right, so here we go. Blessing, line 1, what are we doing?
We're going to declare an async function called createFlow.
Excellent. CreateFlow is defined. It is a function. It is a brand new type of function, an asynchronous function. Good. Line 2, Blessing.
We're going to be invoking the function we just created, which is createFlow.
Excellent. We're going to invoke.
You're going to invoke is create flow here.
And we are going to immediately enter its execution context. Immediately enter its execution context. There it is. And what is the first thing, Blessing, that it tells us to do in this execution context? Let's say at about 1 millisecond.
To console.log me first.
Excellent. So at about 1 millisecond, we hit our console log me first. So we do go into the this isn't like our generator function we have to trigger going into using the next method that the call to the generator function.
So this is now when we trigger is the async method, the next method in our generator.
Returned out the next method on that object. Instead, we're going to go into it directly ourselves just by calling it. So the first thing we do is indeed.
Exactly. So this async and away what it's doing is that, hey, I'm going to now trigger this by calling is the next. Okay.
Log of the string
and then
first.
yield.
And in our memory, what is the next line of code, Blessing, that we are going to encounter?
We declare a constant data.
Perfect. There it is. And for now,
You're gonna console log.
Undefined. Exactly. So we
And declare a data undefined.
data is going to be the evaluated result of that expression on the right-hand side. So there it is on the right-hand side. We say
The evaluation
wait,
of the right expression.
fetch the return of our wonderful final call to our fetch facade function, a two-pronged function that in JavaScript returns out a what, Blessing?
A promise object.
A promise
Exactly, the promise object.
But it also spins up a bunch of work in the web browser itself. So let's do the JavaScript piece first. We are going to return out a promise
Object here.
just as Blessing said,
We'll take
with
the
two-
value,
it has a few properties, but two
the
important
state,
properties, value,
as well as the
fulfillment, which is
unfulfilled.
an empty array. Both right now, nothing interesting in them yet. The value is going to be auto-filled in with whatever comes back from the web browser features, background work, and the on-fulfillment array, well, we'll see what that's going to do here. Good. But, and that object here, we're going to hold it here for now. But in the web browser, what are we spinning up? We are spinning up the background feature XHR. There it is, XH/will elf and completion. So we know that we're referring to this object we defined, its value property. That's what we're going to update. We didn't give it a label in JavaScript, but the web browser knows where that object is stored, and that's the value property is going to update. Okay, perfect. Good. And now the all-powerful await is going to throw us out of the create flow execution context. Have a very clean eye. We're going to throw it out of our create flow execution context, where we are going to flow.
So the await is gonna
now the all-powerful await is going to throw us out
from that.
Create flow execution context. Have a very clean eye. We're going to throw that out of our create flow execution context. where we are going to encounter what line next? Blessing.
Console.log me second.
Me second, exactly. At about, let's say maybe 2 milliseconds, something like that. About 2 minutes. In other words, the most important thing we wanted to do with any asynchronous work is set up a task that takes a bunch of time. That's the web browser feature task to speak to the internet. It's going to take 200 milliseconds. Set it up, but be able to continue running asynchronous code.
It deal out, it kick
to
out
do it,
that
set up
from
our function.
us.
And wouldn't it be wonderful
That's
if we could step back
intrinsic.
in to our function to when we get the value from the request back as a response, hopefully it's going to be stored in data and we can then continue running our code and log that data. Wouldn't that be wonderful? Let's hope it is possible. So in JavaScript now we don't really have much interesting
We don't have
stuff to do.
anything.
We're
Exactly.
done.
We don't have anything there.
We're done. But there's our call stack. But in the background, after about 200 milliseconds, interesting stuff is happening. About 200 milliseconds later, say 201 milliseconds, our background work is complete, and we get a glorious response. Pen is now thoroughly dead. We get a glorious response. Let's use red. A glorious response. The string hi. And what is that going to update? That is going to update our value
On the
property
promise.
of the promise object that's been stored in memory and referred to its position in memory from the web browser feature, ready to update that value. At which point, what are we going to do? We are going to trigger, and we can think of in our on-fulfillment array as effectively the continuation of our create flow execution context. We're going to trigger at that moment the continuation of our create flow execution context, and at about 201 milliseconds, re-enter where we effectively paused. We're going to get to re-enter, add create flow back on our call stack.
Exactly. Back on a
back
call
in.
stack.
And the await fetch, await was super powerful. It threw us straight out. We never even got to assign anything to data. That's not a bad thing. We're hoping that data is going to be filled in with whatever this right-hand side evaluates to. And what does it evaluate
Whatever
to?
right side of it is
Hi.
evaluate.
To the value
to the
from
high.
the request to the internet that came back with hi.
And in this case is the promise, my friend.
That is what our await expression evaluates
Or
to.
hi.
And we assign it to what label? To data. Exactly. And so when we hit our next line in the body of our create flow function, console log data, data is going to be evaluated to hi, and look at that. At about 202 milliseconds, we get to continue running the rest of our code. We get to continue running the rest of our code inside our create flow function. All that work of returning a value, or the response object that we saw before, into the promise object that we stored in future data, that we then triggered a do when data receive function, that then triggered .next on the return next element call, or return next element object next function that triggered us to go back into create flow. All of that automated. The async function definition is going to handle all of that for us. The await still behaves similar to a yield. That we're going to hold on storing anything on the left-hand side until we get something back from this
And then
background
we're
work.
gonna kick
But now
out
when the
from
value
that.
comes back, we're just going to go straight back into create flow and store it in data. This is a beautifully cleaned up version of that highly complex setup we had that was nevertheless a very powerful setup, but now we have a cleaned up version. And by the way, this cleaned up version behind the scenes is doing all of this. So if you want to emulate the async await function definition and call, we can do it ourselves with generators. And this is the senior dev interview question of the next few years.
Okay.
This sort of under the hood understanding of JavaScript is the foundation of getting a senior developer position or a mid-level developer position. It's also deeply satisfying. So I run Codesmith, a community of people building compelling open source projects, whether it's Reactide, an IDE for React, whether it's a remarkable Kubernetes tool that was developed by a great group in New York at Codesmith in the last month or so. All of these are built as part of the Codesmith residency, a collection of people who are saying, I want to go deep on JavaScript, and that's my goal. I want to be part of a community to do it. And as a side effect, at the end of this 12-week, 100 hours per week residency, yeah, they go and get very nice roles. Applications for Codesmith open every 7 weeks for the next 12-week cohort. While if you attend online, applications for Codesmith open every 7 weeks for the next 12-week cohort. While if you attend online the hard parts workshop that moves through some of this material live online every week, you get access to a special challenge code that guarantees you interview if you complete the coding challenge. There is also a regular online application. I encourage you to try it. It gives you access to the Codesmith interview if you put together a very nice collection of words about your background and what inspired you down the path of software engineering. So I encourage you to complete that challenge, but also I encourage you to look into a new online part-time program, Codesmith CSDL. CSDL, Codesmith, Deep Learning. 4 weeks, live online, evening, weekend, where you get the chance to build neural networks from scratch. This is very nice. Every 2 months, I think it kicks off. Go to Codesmith, you can go have a look at that program as well. All right, we have done it. We have made it through the day. Pure, no cuts. 1 cut. We made it through the day with clarity, and all of you should feel genuine pride. Every last one of you. It's very, very special to have seen how far every single person here came in their quality of technical communication. That's what's most special for me. In the end, what makes a great senior developer, which makes
You need to
are,
practice,
and
man.
some of you are aspiring to,
You need to
is the
practice
ability
a
to
lot.
take any
You need to
feature
practice
and
a
empower
lot,
one's
a
team
lot,
to
a
build it
lot.
out
You need to
with you.
practice a
And
lot,
that
a lot,
is
a lot,
based
a
on the
lot,
quality
a
of
lot,
technical
a lot.
communication. And there are multiple people in
That's the only
room
way,
today
bro. That's the
who
only
talk
way.
through their
And you
code
by
with a level of
exposure,
clarity
so expose yourself to that
tremendous
and
mindset.
practice.
This is not
Make
something which we
errors,
have
make
all
errors,
made
and from
inherent
those
and
errors
demanded
you
of day to day, and yet
update
it's the
that.
thing that accelerates engineering teams. You often say, when I add a team member to my engineering team, I go from having one engineer to 1.3 engineers, not from 1 engineer to 2 engineers. If you improve your technical communication, which is really the essence of what we're doing when we're diagramming through, you take yourself from 1 engineer to genuinely 2 engineers, maybe more, maybe a multiple, because you've now shared your internal mental model of the code. It is now a shared resource between you and your team members. And that's very empowering and very special. So, today, we saw all of the hardest parts of the new spec of JavaScript, ES6 and ES7. We saw the foundations of JavaScript that led us on this journey. Memory, thread, execution context, call stack.
Exactly, the foundations.
We saw that get augmented by a whole
All
new
this
set
get
of pieces of that
augmented
architecture.
by the
web browser
architecture.
features, the callback queue, the event loop. We then discovered there's a new built-in asynchronicity feature of JavaScript, our promise objects, whose deferred functionality is not assigned to the callback queue, but to the microtask queue. 2 additional pieces of our model. We then added this whole new way of thinking about how collections of data
can be
and then have
accessed
functionality
through
applied to them, known as iterators.
Iterators.
We rethink collections of data as, instead of being static things we go and get elements from, instead these beautiful flows of data that when I run a function, switch the tap on, I get the next element. Switch it again, get the next element, like a stream of data that I can access and bring. I think it's very beautiful. And then we discovered we could control the nature of
the nature of the flow of that.
Ourselves manually.
Exactly.
Not
We
to
can
rely on
control,
a
so that we can now
structured
have this
set of
way of
data,
how we
but
can
instead
access
dynamically
data, but also we
create
can
those
create
sets of data.
we can
Dynamically
control the
create
flow
those
of all of this data
by defining
are
in a function and
generated
setting ideal
in a
keywords to
generator.
return out those elements as we went. And then we
But defining is a special functions, exactly. But defining is a special functions that using the yield keyword actually is now produce all of this data, and we can control which data we want to generate.
we realized what that was doing was allowing us to exit and re-enter an execution context. In other words, begin the calling of a function, leave it, and come back. And that is what lets us rethink our asynchronous code. It gave us, in the end,
That's something interesting in here, because especially when you are now using the async in a way, what it's doing is to get into this execution context and then get out from that. And when that is done, thanks to the mechanism of the microtask, okay, which is after all using the await and the fetch, returns a promise for that. Now we were able is to, thanks to the await, actually get us the data from that. It's being able to extract the data from the promise. Oh my god. Oh my god. It is being able to extract the data from the promise, the await, and the end docs. Is being able to extract the data from the promise here. Exactly. An expression must be a promise, okay? And you return the value. This is in Spanish. in English, which is a promise or a attainable object, or any value to wait for, okay? So return value is the fulfillment value of the promise, which is what is doing behind the scenes. Is not now, is getting is the data when we need it. All right, so we don't actually have to call or sell the this promise and then .then, and from there actually get by passing this a callback is to actually now is get the data. No. We actually can have the ability to automate this process of now, instead of running the promise .then methods, so we can get in there and actually access our value that we're getting from this promise unfulfilled. Now is automating that process for us and provide us the value as it is. Holy moly. Descriptions and return value is also an exception. Throws the rejection reason if the promise or attainable object is rejected. That's interesting. So let's see if that actually works as expected. We're going to define is our async function here. So async function here as well. Let me use this. Say test fail or async fail, okay, and then I want you to define this async as a function expression, and now I want you to await is for this promise dot reject, okay, with a new error, say error. You say oops, okay, and then you're going to call now the async, okay, the async fail function here. It tells that, hey, there is what? Unexpected token. Of course. Is this one. As it is. And as you can see, now it's throwing that error for us. So if we run that function again, okay, the value that we expect to get here, which is value, okay, when we actually get the value we get is now the promise, of course, because we are not returning that. We can also say something like this. We can wait for that, okay, data, all right, and then I want you to return is the data. So by defining is this, you're supposed to actually throw is or get is the error as it is. So by defining this as say this is the data here, and when we get the data as it is, so now our data is a promise for that, with the state rejected and the reason as it is, meaning that even though that we are returning that, promise resolve, done. Okay, even though that we are now doing is this, and we want to get the data. Okay, it is interesting because this doesn't return that. Okay, because it's inside of this. It's inside of this that we can have access to the data. It's because inside of this generator function. And again, we receive is this, like that, cons data. But in the context of the fetch, that actually is giving us that data as we expect. So public APIs here. It just wants to hit data from one public that actually don't have any cores. For example, based on the standard docs here. Okay, that's right. So if we're now using is this, like a fetch, this built-in method here, and say, hey, I want you to now is called to this. Now this data, because this is different in the case of a promise, okay, so the return value is the fulfillment value of the promise or tenable object. If the expression is not tenable, the expression's own value. So by doing now this and returning that data, we are now saying is now async valid. Okay, async valid. Okay, the declaration of cons, of course. No problem. Then you say the data here. It say, hey, type network error when attempting to fetch resource for that, because that's not the way. And now the data here is a promise. But again, the whole point of this is to look at now that after that is where we're gonna get our data. Okay, after that is when we're gonna get our data, or in theory. So when we call that, all right, it says like, hey, no. This is not what we expected. In return is an uncaught error. It's actually throw an error. So that's what we need, is to attach that into a throw error. An async invalid. Exactly. So if we now correct this, okay, if we now correct this and we run it, it's a network attempting to do that when attempting to fetch reserve. Isn't that the API? What the fuck? Okay. Exactly. Okay. And there you got it. Okay. Maybe Firefox doesn't allow us to do this. That's what happened. But now we get is that, as you can see here, this is responding is with that. So once we get that data, okay, so now we resume the function execution context here with the data. Holy schmoly. Response type basic URL like this, and redirect false, and status 200, and okay, true status text as it is. But this actually happens. This actually happens once the server reply with that. So now this is the browser here when say, hey, we get the value here. Let me update the value of the promise objects, okay? And now the fetch say, I'm going you to return is this promise with the unfulfilled value as the response object, like this. And now the await, what is going to do behind the scene is that not only entering into that execution context, but after you get that data, give you that, all right? So it enter into the GIL context, it go into the generator function first to execute this fetch function, and when that is done, all right, we're now going to attach the promise.then callback to actually call is a generator function to actually call the generator function next method as a way to now provide is a value to this. So all of this back and forward thing is actually achieved by the async and await for that. And this is, oh my god, this will definitely will be is a senior question
async
for
await,
that.
where we enter a function to initiate a background slow task, an asynchronous task, and then only return to that function, leave it, and then return to that function when we get our response back from the slow long-term task. These are all the core features of the new JavaScript spec, the new code. It gave us, in the end, async await, where we enter a function to initiate a background slow task, an async
To initiate is a background task.
and then only return to that function, leave it, and then return to that function when we get our response back from the slow long-term task. These are all the core features of the new JavaScript spec, the new features of JavaScript in ES6 and ES7. So very well done, everybody. I was absolutely delighted by how well you talked through the code, and I am very, very happy to have had you all here along with me today. Thank you.
Mm. All right. 1 hour. Okay, cool. That's perfect. Exactly. Improve my technical communication when using and solving data, and when using data structure and algorithm to solve client's problem. And last but not least, promote exactly. And last but not least, promote the work that CodeSmith is doing to help to help the community to improve. To help the community improve. Exactly. What is this? Write your code below. If you're having trouble using line 12 and 13, what is this? Skipping the challenge will not affect your mission. Please code your solution in JavaScript. You have your code. You have your code marked as complete. Click either the run code and check my answer. This will run your code and you will see the green check mark that has. You're giving an array and names along with an array of phone numbers. Okay. Using a loop, populate the existing phone book object to build a proper phone book. Okay. Using a loop, populate the existing phone loop object. Okay. So using a loop, populate the existing phone book object to build a proper phone book with the keys being people names and the values being their respective phone numbers. There's several alternatives here, by the way. I know what to do, by the way. I know what to do, but I would like to ask ChatGPT what will be the answer here, to see if he know how to use this advanced concept. No, I mean this is quite simple. This is quite simple. Let me see now. Talk to Claude. Because the solution that I give you is quite basic, you know. It's like, it's not anything that special here. Okay. Yeah, provide a ES7 solution. Here is object from entries. Where now the object from entries transform a list of key value pairs in an object. Exactly. So now it will transform here a list of key value object here, which is cons phone book. I'll say object dot entries object dot entries. It will transform is this key value, is this pair, this iterable pair. Okay, it will transform this iterable pair into an object. I'm going to iterate through each one. Exactly. I'm going to create. Oh, okay. Yep. Exactly. It's like I'm going to create now is these collections here. I'm going to create now is these collections here. When you say names dot map, okay, or you say you can even use this redos for this shit. Object dot entry. I want you to transform is this key value here, where this is the name, okay, in which I'm going to return now is in which I'm going to call now is the numbers to say, hey, I want you to return is now the number here, where now I'm going to return is this. Is this key like name followed by the numbers, right? Number. Here we'll be very much more cleaner about our intent. Oh, this is what I would like to return here. Okay, but it's like it's this one. Exactly. Exactly. Oh, okay. Now we can quickly iterate through that. And the another, instead of putting actually more obfuscated that it can be, you say names dot for each. Okay, for each one of those elements, you're gonna get is the name, and this is the callback that you're gonna pass. I want you to now run is the numbers for each as well method, where now I want you to do is this. No, in fact it's just only one, because they have the same length. Okay, we can say is, hey, I want you to now update this object. Okay, update the object with phone book with the name. Okay, followed by the index or the I here, followed by the index here, where you say, hey, now give me is the value of the phone book will be is the value of the name, and their value will be is phone exactly phone book name. The key will be is phone book value okay. The phone book name will be numbers index. Will be the numbers at that position. Oh, the what the hell? Is this one? I already know that. Mhm. All right. So that'll be for this video. All right. Take care. Bye bye.